video, I will explain a question in probability related to number of children in a family. So the question is saying that a family has 3 children. Find the probability that the second child is a boy, 2 of them are girls, and at least 1 of them is a boy. So the first approach when you have a probability question is finding the sample space sets, which we showed with S. So what was the sample space? Sample space is a set that contains all the possible results. So when we are discussing about the children, the gender of children, so we have 2 options, boys or girls. So, and we have 3 children. So the first possible thing is going to be all the children are, let's say, girls. So we have 3G here. After that, let's say 1 of them is a boy. So it's either the first one is a boy, other ones are girls, or the second one is a boy, or the third one is a boy. Now let's switch to 2 boys and 1 girl. So I have 2 boys, 1 girl, so BBG, and then maybe the second one is a girl and the other ones are boys, or maybe the first one is a girl and 2 other children are boys, and the last one is going to be all the children are boys. Okay, so now how many possible results do I have here? As you see, these are 8 items, so I can say the n of S is 8. By the way, there is another way to find that number, which is using this formula. This formula only works when you are discussing about the number of children in a or the gender of children in the family. So then n of S is going to be 2 to the power of number of children. So for example, in this scenario we have 3 children, so the number of S is going to be 2 to the power of 3, which you know that this is 8, the same answer. So for example, if you had 4 children, then the number of items in S is going to be 2 to the power of 4, which is 16. Okay, now you know that the general formula in probability is the number of event over the number of S. So we know that the number of S, the number of items in S, is 8. So I can use this 8 in all the sections of the question. So I'm going to write P equals, in the denominator is S, for this one is again over 8, and this one is again over 8. Okay, now I have to find the number of items in event in each section. Okay, let's discuss the first one. The first one says the second child is a boy. So we are not caring about the first one and the third one. From these list of boys and girls, you have to choose the ones who have the second child as a boy. So for example, the first one is not okay because the second child is a girl. Again, this one, the second child is a girl, but this one is good, so I'm going to pick this one. This one is not good. This one, the second child is a boy. This one is not. This is okay, and this is okay. So how many answers do I have here? It's going to be 1, 2, 3, 4. So the number of this event is going to be 4. So I'm going to write 4 here. And as a result, 4 over 8, you know you can reduce it, which is going to be 1 over 2. So 1 over 2 is the answer for part A. How about part B? Part B, it says 2 of them are girls. So again, you have to look at these possible answers and find the ones who have 2 girls and obviously 1 boy. So the first one has 3 girls. So by the way, when it says 2 of them, it means exactly 2, not more than 2, not less than 2. So the second one has 2 girls, so this is good. I'm going to show this one with the green. The second one here, the third one is okay. This is 2 girls, 1 boy. Again, 2 girls, 1 boy. So this is not okay because it is only 1 girl, 1 girl, 1 girl, and there isn't any girl here. So as a result, how many items is acceptable. Here we have 3, so the answer is going to be 3 over 8. I cannot reduce that fraction anymore, so you have to leave it like that. In part C, it says at least one of them is a boy. So here you have to find, when it says at least one, that means one or more. When it says at least one, that means one or more. So I have to look at again the list and find the ones who have one girl or more than one girl. So the first one has 3 girls, so this is good. I'm going to show this with black. So this one is okay. This one has 2 girls, again it's okay. These ones as well, it has 2 girls. This one has 1 girl, so again it's acceptable. 1 girl is okay, again 1 girl is okay. And the last one doesn't have any girl, and we need at least 1 girl, so this is the only one that is not acceptable. So how many items are acceptable? 1, 2, 3, 4, 5, 6, 7. So the answer is going to be 7 over 8. I cannot reduce that fraction anymore, so you have to leave it like that. So this is how you solve the basic problems in a number of children.